Hello, this is the third part of the video series on simultaneous equations. In this video, we are going to go through how to solve simultaneous equations graphically. So basically, when you have two equations, it could be two linear equations, it could be one linear equation, one quadratic equation, depending on what you have. But in this video, we are going to look at two linear equations, how we can plot them on a graph, and how we can obtain the solution. So if you have two linear equations, by linear equation, I mean the degree of the variable is 1 in both cases. The highest power of x is 1, the highest power of y is 1 in the two equations. So what do? You plot your graph. So let's say you have the Cartesian coordinate, then you plot the first equation, so it gives you a straight line, and the second equation gives you that straight line. Then the point of it as intersection of the two will give you the solution, basically. This is going to be a rough sketch because we are not going to use a graph, but I'm going to show you how you can obtain the values for the corresponding y values for the x values you are going to use. If you have one linear and one quadratic equation, so you will plot the quadratic function. Let's say the quadratic function looks like that, and you plot the linear function, and that gives you that. So the solution will be that. So that means you're going to have two different solutions. I mean, two values for x and two values for y. But in this case, you're going to have one value for x and one value for y. Okay, so let's see an example. So the question is, for a range of values of x from 0 to 5, obtain by graphical method the solution of the simultaneous equation. So x plus y equals 6 and 2x plus minus y equals 6. So what we want to do actually is to first generate the table that shows the values of y for each values of x. So that's one way you can do that actually. So if you generate the table, here you're told the range of values to use. So the x values, 0 to 5, 0, 1, 2, 3, 4, and 5. Then the y values. So we need to get a y for each of the equations. So if I make y the subject of the formula here, y will be 6 minus x for this equation. So y equals 6 minus x. And for the second equation, y will be 2x minus 6. So if you move y here, you move 6 here, so you have that. So y will be 2x minus 6. So I want to get the values of x or of y for each values of x. So when x is 0 here, so what do I get for y? So 6 minus 0, that's 6. So 6 minus 1, that's 5. 6 minus 2, 4. 6 minus 3, 3. 6 minus 4, 2. 6 minus 5, 1. So for this, when x is 0, y will be minus 6. Okay. When x is 1, y should be, okay, let me write it out. Y equals 2x minus 6. So when x is 0, y will be 2 into 0 minus 6. So y will be 0 minus 6, and y will be minus 6. So that's when x is 0. So when x is 1, then you have y equals 2 into 1 minus 6. Y will be 2 minus 6, and y will be minus 4. So minus 4. Then for this, when x is 2, you have y equals 2 into 2 minus 6, y equals 4 minus 6, y equals minus 2. So that's what you do for all of them. So if you complete the table, you will have for x equals 3, 3 times 2, 6 minus 6, 0. X equals 4, 4 times 2, 8, 8 minus 2 minus 6, 2, 5 times 2, 10, 10 minus 4, minus 6, 4. So I have the data. Then what I have to do is to plot the graph. So this is a sketch, the rough sketch, basically. So this is 1, this is 2, this is 3, this is 4, and this is minus 1, minus 2, minus 3. Okay, I think that'll be too sharp there to manage my line properly. Try it again. So if this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. This is not drawn to scale, it's just a sketch. So I stop there because I know that the smallest value of y there is minus 6. So this is 1, 2, 3, 4, 5, 6. So the highest value of x is 5, so it's 5. So when x is 0, y is 6. For the first line, so I'll plot the first line with black, this is my black ink. When x is 0, y is 6. Okay, I have 6, so I need to go up to here, 5, 6. So there. So this first point. Second point, when x is 1, y is 5. Oh, sorry, an error there. 0, y is 6. That means it should be here on the axis. X is 0 on the y-axis. So when x is 1, y is 5. So it should be there. So when x is 2, y is 4. So this is just a rough sketch. When x is 3, so if you plot this on your graph, you should get the exact value for x and y. 4, 2. So you go to x equals 4, then you go to y equals 2, and you get the point. And when x is 5, y is 1. So 1 for y and 5 for x. So that's what you get. Then I can plot it. This is a line. Then for the second line, I'm going to use red. When x is 0, y is minus 6. So that should be there. Oh, sorry. What's it? Yeah. Okay, when x is 1, minus y is minus 4. So that should be here. When x is 2, y is minus 2. Okay. When x is 3, y is 0. That should be on the axis. When x is 4, y is 2. When x is 4, y is 2. You can see the intersection clearly there. And when x is 5, y is 4. So I plot the line, and I have that like a rough sketch. So you can see that this one should be here. It means that this one should be here basically. Plots properly. So this is the solution. You can see where the two lines intersect. So the coordinate of the point of intersection of the two lines is what gives the solution of the simultaneous equation. And that will be y equals 2 and x equals 4. That's where they intersect. So the solution will be x equals 4 and y equals 2. Okay. So I hope that is clear enough. So we stop there and I will see you in the next video. Bye-bye.